for this section. One is to be able to write the equation that represents the conic section on a rotated set of axes, and the other objective is then to be able to graph it on the rotated axes. We'll do the graphing part tomorrow. So today we're going to focus strictly on like getting the new equation, okay? And that's where the algebra piece is really coming in. So this I do not think you need to write down. I just want to talk really quickly about the differences from 10.2 to 10.4 versus what we're doing today. Do you remember in 10.4 when we talked about, or actually it was 10.3, 10.4, when we talked about writing the equations of hyperbolas and ellipses? I showed you this general form, ax squared plus cy squared plus dx plus ey plus f equals 0. And someone probably said to me that day in class, why did you skip b? Yeah, okay. And I said, actually, there really is a b. It's just the coefficient to the xy term. Okay, so this is what the graphs look like, what we were always doing before. I'm drawing an ellipse, but I could have parabolas or hyperbolas there. They either have like vertical major axis or vertical symmetry or horizontal major axis, horizontal symmetry, that type of thing. When I introduce, and again, I don't think you need to write this down, I'll have you write stuff down on the next slide. When I introduce the bxy term right there, then my conic rotates. So it's not going to be vertical major axis and it's not going to be horizontal major axis. You could imagine the major axis there as some kind of sloped line. Okay. So what we're looking at in 10.5 is equations that have the xy term and how can we get them to a point where we could graph them. Okay, so we're going to use a tool to be able to do that. On the next slide, you should write this down, okay? There are new rules for classifying your conics from the general equation if we introduce a value for b. Okay. So we did not necessarily have this same rule, and I actually, when we did this that day when we were writing equations, I said, you know, like, we can write down mathematical rules with a and c, but what I would really focus on is like your x squared and your y squared. Are they the same sign with same coefficients? Then it's a circle. Are they different signs? Then it's a hyperbola. Is there only one x squared and not a y squared? Then it's a parabola. Okay. B messes everything up. Okay. You can't look at an equation that has a bxy term and know just by the x squared and y squared if it's which conic section it is. So you have to use this b squared minus 4ac. Does that look familiar to you, b squared minus 4ac? What do you remember it from? The quadratic formula. Do you remember what its name is in the quadratic formula? It has a name. Mitchell? The discriminant. Very good. Discriminant. So if you want to jot that down, just so that you have that for reference, you can. Okay, we're going to use the discriminant, and we still call it the discriminant. Okay. But now the discriminant, instead of what we used it for in Algebra 2, which is to decide how many and what type of solutions we have, like do we have 2 real, 1 real, or 2 imaginary solutions. Now we're going to use the discriminant based on whether it's negative, 0, or positive to determine what conic sections we have. So if your discriminant is negative, it will be either an ellipse or a circle. Based on the discriminant, we will not have enough information to decide definitively which of those two it is. You will be able to determine if it's an ellipse or a circle once you rewrite the equation and you have that final equation. Okay, so you'll know at the end of your equation. If it's equal to 0, it's a parabola. And if it's greater than 0, it's a hyperbola. So this is going to be a key piece for us at the beginning of every problem that we'll do. We'll do one example, and then you guys have 4 homework assignments. you should do this at the beginning of every problem, is figure out which conic section it is. Yes?
But does that tell us that it's not just to this quiz?
No. Well, I mean, you could have used it, but we went over that in the writing equations notes.
What part is the discriminant?
B squared minus 4ac.
Oh,
All of it is the discriminant, yeah. So in the quadratic formula, that's the stuff that's under the radical, right? Very good. Okay, so you will, for the next problems, just need to remember in this general form, A is the coefficient to x squared, B is the coefficient to your xy, and C is the coefficient to your y squared. Okay, and then the x, y, and number term are other letters that aren't in the discriminant. So could you tell me which conic section these are? So do a little calculation. Use your discriminant. In that first one, my A value, coefficient to x squared is 2, my B value, coefficient to xy is 1, and my C value, coefficient to y squared is 2. So I'm going to go ahead and do my B squared minus 4ac. That would be 1 squared minus 4 times 2 times 2. That's 1 minus 16, which is negative 15. So you would tell me conic is ellipse or circle. Okay. Again, we won't be able to say which one it is until we rewrite the equation, which we're going to go over next. And you'll be able to tell, like, does it have the same coefficients, then it's a circle. If it has different coefficients, then it's the ellipse. Next one, similar idea. I would do b squared minus 4 times a times c. So that's 4 minus 4, which is equal to 0, and that's a parabola. And then something that can kind of throw some people off is if they saw this last equation, xy minus 8x minus 4y equals 0, they might think, well, that's not a conic section that I know because it doesn't have x squared and y squared, right? Okay. But this is something different because of the bxy that throws everything out. And all that means in this problem is our b value is 1, a and c must be 0. So we would still do 1 squared minus 4 times 0 times 0, which is going to be just 1, so it's a hyperbola. So don't let that throw you off if the general form does not have x squared and y squared. Eventually it will when we rewrite the equation today. But right now that's considered a hyperbola. And the reason why is it has this strange term that we've really never seen before, xy. Okay, so what are we going to do with that, right? That's the big question. Any questions on classifying the conic? You could use that like on the quiz yesterday. Of course, your b squared would have been 0 every time, right? So you'd really just be doing like your minus 4ac. And the one thing that would be different is we could actually yesterday tell the difference between ellipse and circles. If there's no b value there, there's no xy term. If they have the same sign and same coefficients, it's a circle. If they have the same sign and different coefficients, it's an ellipse. Okay, so without xy, I think just looking at the x squared and y squared terms is probably easiest. Okay, so here's where we get into the work of what we're going to do today. Okay. We're going to rotate the axes of the coordinate plane to eliminate an xy term. we don't know how to graph them with that XY term there. Okay, it doesn't look like standard form. And we can't get it to look like standard form. What do you do with X and Y? So I'll give you a minute to write this down. There's much to follow it as well. On that second equation, those are primes. Do you remember those from geometry? Apostrophes, basically, but we call them prime. So everything has a prime on it. Hello. Are you looking for Miss Kelly?
I am.
She may be in the math office. I would check there.
Thank you. Sorry to hear.
No, that's all right. Okay, so what we're saying here is you have that very first equation, which has all the coefficients, including the b, right? Okay, so now we've introduced the bxy term. Well, we can't change that equation as it is into standard form, because if you think about how we change things into standard form, we put like our x squareds and our x's together. We put our y squareds and our y's together. We work to complete the square and rewrite it, right? If you wanted to complete the square, where would you put, or like really, what would you do with the xy term? Does it go with the x's? Does it go with the y's? Can you use it to help you complete the square? It kind of just gets in the way. So like this xy term is a real big problem for us, which means we're just going to find a way to get rid of it. Okay? And that's why in the second equation, the big difference is there is no b prime, x prime, y prime. Do you see that? Okay, it goes back to that old general form where there is no b term, and then I could get this general form with a prime, x prime squared. I could get this into standard form. I know how to do that. Group my x's, group my y's, complete the square, okay, all that jazz. Okay, I could do it with this. The reason why it has all those primes, think back to what primes did for you in geometry. Probably the first time when you were introduced to the prime as a notation, it was like you had a triangle ABC, and then you were going to do some kind of transformation. Like maybe you reflected it over the y-axis, and then when you reflected it over the y-axis, you labeled all the new points with primes, right? A prime, B prime, C prime. You have a new triangle. Triangle A prime, B prime, C prime. So what we're saying here is these are new values. They're not the same. So it's not like we're just going to like cross off bx, y and be done. Okay? They're new values, but they're representing some kind of transformation. And the transformation that we're doing is rotation. So we're rotating the axes. Okay? So it continues and it says how we can rewrite things. Okay? So this is how we're going to rewrite it, the next step. By rotating the coordinate axes counterclockwise through some angle theta, where we know theta to satisfy one of these two equations. So I'll go ahead and give you some time to jot this down. You could use either of the two equations that I'm presenting you with. You'll see in my work, I usually stick to tangent to theta, only because when we look at our unit circle here in a little bit, like I'm more comfortable with tangents of angles on the unit circle than I am with their cotangents. I know they're just reciprocals, but I know the tangents really well. So I actually use the tangent equation. You could use either one that you want. Notice that in both of these, they have A, B, and C. They're the same values that you would use for the discriminant, so they're the coefficients from the original problem. Okay, so that's where you're pulling those numbers from. I'm just going to show you really quickly what I mean by this statement, and remember tomorrow is the day we actually do the graphing and the visual piece of this. But basically what this is saying is you have a normal XY plane that you have always graphed on. X is horizontal, Y is vertical. Done. Okay. In order to get these rotated conics, we're actually going to imagine taking the coordinate plane and rotating it counterclockwise some angle. So let's say my angle was like a 30-degree angle. Then I'm going to take my x-axis, which is horizontal, and rotate it 30 degrees counterclockwise. And that's my new x-axis, which I would call x-prime axis. Okay. And then I would also have to rotate my y-axis the same angle, 30 degrees counterclockwise. So my vertical axis would rotate 30 degrees counterclockwise. Okay. And that would be my y-prime axis. So my new y-axis. If you can kind of like just focus on the red axes right there, it's really like the same coordinate plane. It's just rotated a little bit. You could just kind of like turn your paper a little bit and then see it like we usually see it, horizontal and vertical. Okay. But this red set of axes is what we're going to be graphing on tomorrow, and that's going to give us the rotated shapes. Okay, and then we have a final statement. So how do we really do this? How do we change all these numbers? How do we get to these new things? Notice that your x's and y's are new x's and y's. So here's how you'll get those values, your new coefficients. The coefficients of the new equations are obtained by making the following substitutions. And you've got two of them, one for x and one for y. So when you're doing these substitutions for x and y, you'll be leaving x prime, y prime alone, and then those will translate into that new equation. There'll be the new x prime, y primes in the second equation. But like cosine theta and sine theta, you'll have found theta in this step above. That's the angle of rotation. You'll be plugging that in, and then you can evaluate the sine and the cosine from the unit circle. So you'll actually be getting number values from the unit circle for those sines and cosines, for the coefficients for x prime and y prime. Okay, and then we'll be able to work out from there. So I asked you if you would to get out your unit circle if you had it with you, your yellow unit circle. I think now would be a great time in your notes, and even if you have your unit circle or don't have your unit circle, to maybe just jot down some information from the first quadrant. Okay, so like you'll be expected to know the values from the unit circle. So just as a quick unit circle review, I'm going to focus on my angles in the first quadrant from 0 to pi over 2. So things that I would want to know at each are their ordered pairs, of course. Okay. So remember here, my ordered pair for my point on the angle 0 is 1, 0. If you're at pi over 6, you're at square root 3 over 2, comma 1/2. At pi over 4, that's square root 2 over 2, comma square root 2 over 2. And at pi over 3, I'm at 1/2, comma square root 3 over 2. And then at pi over 2, I'm at 0, 1. Okay. So like if you come up with your angle of rotation is pi over 6, then you'll be using square root 3 over 2 for the cosine. You'll be using 1/2 for the sine, and those will be your coefficients to your x prime, y primes. The other thing that would be helpful that you know from that very first quadrant would be the tangent values. Okay. So just really quickly, the tangent of 0 is 0. The tangent of pi over 6 is square root 3 over 3. The tangent of pi over 4 is 1. The tangent of pi over 3 is square root 3. And the tangent of pi over 2 is undefined. So those are also really helpful things to kind of jog your memory. So if you see those, you kind of know what angle to answer. So it would be a good idea to review those things. And you can keep your unit circle out on your desk so you can refer to it. But definitely make sure that you feel comfortable. Next Wednesday and Thursday, I believe, is your exam for the test. Yeah, for chapter 10A, Wednesday and Thursday. So you need to know those values by that point, right, without looking at your unit circle.
If we're gonna be gone for AP testing one of those days, do we need to
Yeah, you'll need to make up the rest of the test. You can do it before, after school, or during a study hall, or the following days are going to be reviewed for the final.
Okay.
So you could do it during a review day, but then you have to find time on your own to review for the final. Okay, so let's do an example. xy plus 2 equals 0. Okay, here's how I would start every problem for today. You have 4 homework problems, right? Figure out which conic section is going to be in the end. So use your discriminant. Okay, that very first thing that we talked about. I'm going to say 1. Classify the conic. Doing it earlier is just helpful because in like all the time you're working, you know what you're expecting to have happen at the very end. Okay, so I'm going to do b squared minus 4ac. In this case, I only have a value for b of 1. A and c must be 0. So again, this is like that other example we did. This is a hyperbola. So I know at the very end of my work, I should have an equation that looks like the standard form of a hyperbola. An x squared and a y squared, there's a subtraction sign. Okay, one of them is negative and should be equal to 1. Step 2, find the angle of rotation. To find the angle of rotation, I use the tangent of 2 theta is equal to b over a minus c. That's the one I prefer to use. And then I just have to substitute in my values. I just used b, a, and c for my discriminant, so I'm really just plugging those things in. So I'd say something like tangent of 2 theta is equal to 1 over 0 minus 0, which is 0. And what would you tell me about that value, 1 divided by 0? Undefined. So I know that the tangent of 2 theta is undefined. Which angle is that on your unit circle? Pi over 2. So 2 theta is equal to pi over 2, which means that theta must be pi over 4. Now, your angle of rotation really should always be an angle on the unit circle, because in the next step, you have to use the angle of rotation to find your new values for x and y that you're going to sub into the equation. And so you have to be able to do the sine and cosine of that angle. So if you're not getting something on the unit circle, then be like, okay, go back and double check. Something must be wrong. Okay, it should be an angle on the unit circle. Okay, so then I'm going to say step 3. I'm going to find the new x and y, which is that little piece where we're going to sub in those values. So when I look back at my notes, x is equal to, and it's x prime times the cosine of my angle of rotation, which is pi over 4, minus y prime times the sine. So I'm just subbing theta in. Theta is pi over 4. Subbing that in for the theta. And then use your unit circle. What is the cosine of pi over 4? Square root 2 over 2. What is the sine of pi over 4? Square root 2 over 2. So we now have our new value for x. Square root 2 over 2 x prime minus square root 2 over 2 y prime. Oops. Square root 2 over 2 y prime. And then I have to do the same thing for y. Okay, new formula. So my new y is going to be x prime times the sine of pi over 4 plus y prime times the cosine of pi over 4. I suggest writing down your steps, showing full work. That way you're more likely to kind of absorb those equations for the new x and the new y, because you need to know those by next Wednesday, Thursday. That gives me y equals square root 2 over 2 x prime plus square root 2 over 2 y prime. And I'm just going to box those so those stand out. Those are the 2 answers I want from that step. Is everybody okay with what I've done so far? Okay, so you're always going to do these 3 things at the very beginning. Okay, and it's just kind of like getting yourself ready. The next step is we're going to go back to the original problem, xy plus 2 equals 0. We're going to sub in our new x and our new y. So we're going to replace those with those things that don't look very nice. Okay, with the x prime, y primes, and the square root of 2 over 2. Okay. So step 4 would be sub into my original equation, xy plus 2 equals 0. I'll write out my original equation, xy plus 2 equals 0. And then I just found out that x was this value up here, square root 2 over 2x prime minus square root 2 over 2y prime. And y is the value square root 2 over 2x prime plus square root 2 over 2 y prime. And you can write plus 2, but if you ever have just a constant value, eventually you want to move it over to the other side. So I'm just going to go ahead and do that now. Subtract 2 from both sides. When you decide to move the number to the other side, it's totally up to you. I just I'm not going to need to do anything with that, but move it to the other side, so I'm just going to get it out of the way now. Okay? Now, this does not look like anything from our previous sections, so it means I have work to do. I'm going to multiply this out. Catherine looks really excited right now, just so you guys know. She's like, yeah! It's false. Okay, so you're going to have to be careful and do a little bit of work. Pay attention to signs, positive and negative, and then pay very careful attention to your fraction work. Okay, so I'm going to start by multiplying the first terms. As square root of 2 over 2x prime times square root 2 over 2x prime. Well, in the numerator, square root 2 times square root 2 is 2, and 2 times 2 is 4. So you can write 2 over 4, or if you want, you could write 1/2. It doesn't matter what you do. I'm just going to do 2 over 4 for right now. If you want to reduce it to 1/2, go ahead. Okay. And then it would be x prime times x prime, which is x prime squared. I put my x prime in parentheses only because it drives me nuts. If I don't, then it looks like x to the 12, and I get really confused. Okay, so if you don't need the parentheses, you don't have to put them there. I like them because then I know it's x prime squared. Now I'm going to do the next set of multiplications. So I'm going to take the outside term, square root 2 over 2 x prime times a positive square root 2 over 2 y prime. Well, I already multiplied square root 2 over 2 times square root 2 over 2. I know it's going to be 2 over 4 or 1/2 again, right? Okay. So this is a positive times a positive. It's going to be plus 2/4, and then it will be x prime y prime. And you could write 1/2 if you wanted to reduce it. You can reduce early or reduce later. I say try to hold off on reducing sometimes because it makes it a little bit easier. You don't have to re-get common denominators. Now I'm going to do my inside terms. This time it's a negative square root 2 over 2 y prime times a positive square root 2 over 2 x prime. That's going to give me a negative 2/4. And then some people might write this because you're doing y prime times x prime in that order. But remember, multiplication is commutative. You could write it in any order that you like. I always try to write my variables in alphabetical order so that they match the other ones. So even though I'm doing y prime times x prime, I'm going to write x prime y prime. They're really the same thing. And then I got one more set to do. It's the last terms in both parentheses. This is negative square root 2 over 2 y prime times positive square root 2 over 2 y prime. That's going to be a negative 2/4 y prime squared. Where's negative 2? Does anybody have any questions about what I have done so far? Just multiplying, just distributing. I know it's not necessarily nice, but it's doable. Okay, what are you excited about? The x prime, y prime cancels, which is what we wanted to do, right? We didn't want that pesky xy term. We didn't know what to do with it. So this is awesome. 2/4 x prime y prime minus 2/4 x prime y prime totally cancels out. Cool. I feel great. That is what I wanted to do. Now I'm going to go ahead and use my reduced values because I don't really have anything else that's going to combine. So this is 1/2 times x prime squared minus 1/2 times y prime squared equals negative 2. And I'm thinking, I feel better about this. This is starting to look more like a hyperbola. Like I've got an x squared and a y squared. I've got one positive and one negative. But remember, in standard form, it should be equal to 1. So what am I going to have to do to both sides? Divide by negative 2, or you could think about it because you have fractions multiplying by negative 1/2. Okay, so however you see fit to change it, you go ahead and do it. I'm going to multiply by the fraction 1/2 on both sides. Oh, sorry, negative 1/2. It's a negative. And on the right side, that's just going to give me my equals 1. On this side, I'm going to have to multiply my fractions, or divide by 2, multiply the denominator. That's negative 1/2 x prime squared plus, or sorry, 1/4. I didn't multiply. Plus 1/4 y prime squared. And I'm feeling really, really good about that. That looks even more like a hyperbola. What could be one thing I could do to clean up my work? To make it look more like the hyperbolas that you saw. Okay, instead of showing multiplication with a fraction, write it as division so that they're over 4. Anything else I could do?
Change the terms.
Yeah, in all of our hyperbola equations, the positive was first and the minus was second. So I'm just going to rearrange the order. So I'm going to do both of those things. That would put my y prime squared first over 4, like Emily told me. And then, like David said, switch it around. So x prime will be second over 4 equals 1. And that looks like a standard form equation that I would have seen in section 10.4 for a hyperbola. The only difference is instead of x and y, I have x prime, y prime. So this is, tomorrow we'll come back and we'll look at this same example and we'll graph the new axes, the x prime axis and the y prime axis, and then we will graph the hyperbola on that. But we can see like A is 2, B is 2, the center is at 0, 0. All of those things remain the same, it's just that it's on a rotated set of axes. Does anybody have any questions? Okay, get out the paper that is going to be your homework. You have 4 problems for homework. We have about 15 minutes. You're going to get started on one of them. It is not the first problem on the homework. The first problem on the homework is very similar to the example that we did in our notes. So I have full faith that you'll be able to do that one. This one is maybe a little bit more complicated, sadly. But maybe also a little bit exciting because it's got some extra values in the equation. So go ahead and jot down. This is number 19 from your homework. So you're doing page 729, 13, 17, 19, 22. So this is number 19. Work through for a little bit. Okay, take a couple minutes, go back to your very first step, then move on to your second step. I'll check in a couple minutes, see if we've got the correct classified conic and the correct angle of rotation. So see if you could calculate those things. Take a quick minute to check the board. Did your discriminant come out to negative 256? So that's a negative value. It would be an ellipse or a circle. Let me know if you're not getting that value. Be careful when squaring 6 squared 30. And in step 2, your angle of rotation should be pi over 6, which I feel good when I get that because I know that that is an angle on the unit circle, so I'm feeling okay with that. Raise your hand if you're needing any assistance or having any questions. And I've got my answer to step 3 up there. So like, what are my values for X and Y, my new X and Y? You can kind of look up there and see if you did that correctly. Again, use your unit circle, but know that you'll be taking your test without your unit circle, so you should be able to evaluate sine and cosine from the unit circle. Now, Nick asked a really great question. Do I have to plug those in for the x squared and the y squared too? Yes. Yes, you do. Okay, so that means you're going to do 3 sets of distribution or FOIL, right? So that's going to get kind of crazy. What I can say to you is this. When I did the homework, I have 4 problems. I have 2 pages, a problem on each side. I just gave myself space. I didn't try to cram it all in. Okay? I don't even always try to cram it all into a single line. Okay, so you can kind of space yourself out so you're giving yourself room to work. That would be beneficial. When you square something, what does it mean you're doing mathematically? Multiplying it by itself. So I'm actually, when I plug in for like 13x squared, I'm just going to write 13 times x. And I'm going to go ahead and write it out twice. That just will reduce the amount of writing that I'm doing, right? So I'm going to kind of set up, this is my step 4 where I plug in. And I would have 13 times x times x, because that's x squared. And then I'm going to leave myself a line or 2 where I can do that work just for that. Like you see on the smartboard, I'm out of space. And so I'm going to leave myself a couple lines where I could work that out. And then I'm going to do, is it plus 6 square root 3? Yeah. Okay. Then I'm going to do plus 6 square root 3 and put in my x and y. Okay, so square root 3 over 2, x prime minus 1/2 y prime. 1/2 x prime plus square root 3 over 2 y prime. And then I'll still leave myself a little bit of space. And you can maybe get 2 of them on a line because you have a notebook and you're writing smaller. So you can maybe get 2 of them on a line. But then maybe like skip a couple lines and give yourself space to work those things out. You can decide. Or if you want to cram everything and then do all the work underneath. It's totally up to you. How do you like to set it up? Okay. So then I'm going to give myself some space. And is it plus 7?
Yes.
Y squared. So I'm going to write y times y. And then minus 16. So I'm going to add the 16 to the other side. Equals 16. Anybody confused about how I stepped into my equation? I know it's broken up into 3 separate groups. So now you just gotta go through and you gotta do 3 separate multiplies. Multiply yours out. See if you can get that same set that I got. Let me know if you're having trouble. Raise your hand. We'll kind of troubleshoot together. You would just, so like when you do negative square root 3 over 4 minus negative minus square root 4, just minus 2 square root 4. Catherine asked me a good question. How do I combine those x prime, y primes if they have radicals in them? It's just negative square root 3 over 4 minus negative square root 3 over 4. It's negative 2 square root 3 over 4. Combine like terms, basically. And my last step that I would do before, I like to do it like one group at a time. Like I'm going to do everything with 13x squared. I'm going to simplify that as much as I can. And then I'm going to move on to my next group. So the last thing I would do is distribute my 13. And I'm not going to reduce my fractions. I'm just going to write 39/4 x prime squared minus 26 square root 3 over 4 x prime y prime plus 13 over 4 y prime squared. I could reduce this middle one, like 26 and 4 are both divisible by 2, so I could write 13 halves. But I'm going to leave it there because, like, what if something else in x prime, y prime term has a denominator of 4? Then I won't have to, like, re-get the common denominator. So I'm going to leave it alone until I start canceling things out. Again, holler at me if there's a question or a concern. Yes, 2 over 4 would reduce to 1/2. But I'm not reducing anything, so you can reduce it. It's just that, like, later, if you're adding it with something that has a denominator of 4 that doesn't reduce, you'll have to get common denominators. So in this work, I really don't simplify my fractions until the very end. It's like negative 1 square root 3 over 4 minus 1 square root 3 over 4. So when you add and subtract radicals, you're just combining like terms. Negative 2 square root 3 over 4. I'll see if I can get mine. I've got a minute or so. Okay, so keep working on this one. Okay, we'll go over some things tomorrow and have some time to work, but we also have to graph.
When am I gonna do
We'll have some things out.
that?